Welcome back to linear algebra. Oh, we got 15 flashcards due. What is a row matrix? A row matrix is a matrix that has only one row. What size requirement must be met for the matrix products A, B to be defined? The number of columns in A must be equal to the number of rows in B. What is required for a sum or difference of matrices A and B to be defined? What is required for the sum? A and B must be the same size. What is a square matrix of order n? It's an n by n matrix. Down in the corner. Assuming A and B have the appropriate, assuming A and B have the appropriate sizes, how might you compute the jth column vector and the ith row vector of AB without computing the entire product? To compute the jth column vector, you essentially take A times the jth column of B, and to find the ith column vector or row vector, you take the ith row of A times B. All right. Assuming that A and B meet the size requirement to be added and subtracted, how might you compute A plus B and A minus B? Assuming that A and B meet the size requirement to be added and subtracted, how might you compute A plus B? You essentially add the corresponding entries and you subtract the corresponding entries. All right, good. What is a column matrix? It's a matrix with one column. What is a homogeneous linear system in variables x1, x2, and xn? Homogeneous linear system in the variables x1, x2, xn. A homogeneous linear equation. X1 plus x2 plus dot 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 plus xn equals 0. There's a corresponding A in front of them all. What are the entries on the main diagonal of an n by n matrix? A equals the entry A at ij. What are the entries of the main diagonal? Essentially from the top left-hand corner to the bottom right-hand corner. A11, A22, dot dot dot, ANN. If A equals entry A at ij, what does A22 denote? It denotes the entry A at row 2, column 2. What is the row column rule for computing AB at ij? What is the row column rule? To find ij, you take the row I of A times column j of B. Down on a corner in the street. What the? Damn it. What is it? Alright. Donkey is lagging super hard. Write out the matrix represented by the symbol Aij 3 by 4. So it's going to have 3 rows, 4 columns, and it's going to be like A11, A12, A13, A14. A21, A22, etc. Good. What is a linear combination of matrices? Essentially, it's just a bunch of matrices the same size being added together, each being multiplied by essentially a scalar. It could be 1. And we're lagging again. All right, good. What is required for 2 matrices to be equal? What is required? They've got to be the same size and all the corresponding entries must be equal. Good. If C is a scalar and A is a matrix, what is the matrix C times A, or CA? Basically, it's the resulting matrix of A, but every entry is multiplied by C. Good. All right, Anki is done. What is next? What is next? What is next? We're going to be grading our problems from yesterday. We're going to finally figure out how to actually compute the inverse because I got stuck yesterday trying to figure it out. So after I'm done grading, I'll be back. One super simple mistake was all it was. You don't switch B and C. You switch A and D, and you make B and C negative. You don't switch them too. So that's literally all it was. I had the numbers right. They're just in the wrong location in the matrix. And then I also calculated A cubed correctly. So it's all right. Now we know how to calculate the inverse though. So I'm going to go and spend the rest of the day working out problems. And then I'll be back at the end to recall what I did and call it a day. All right. So number 9 is what we started on, which was find the inverse of this bunch of exponents, essentially. Natural. Is that natural log? Is that E? No, that's ln. Is ln the same as E? I don't know. I don't know what that is then, I guess. Maybe it's the natural log. I don't remember exactly though. We had to find the inverse of this, and so like I know how to find the inverse. It's just kind of like all this algebra and arithmetic that I don't know. We're gonna see if I got it right tomorrow. If I got this right tomorrow, I'll be very happy with my understanding of commutative laws of multiplication, distributive laws, and exponent laws. So hopefully we got that right. We'll see. Next we have 11. This was just proving that these two are equal. So that was easy. Interesting though that the transpose of A, the inverse of the transpose A is the same as the inverse of A transpose. Interesting. But yeah, we just did it. We just showed that. I mean, that's not a proof, but they said prove it. So by this example, so I'm pretty confident. And then this one was finding the inverse of 7A. You find A from that, given that this is true. So I think we got that as well. All right, that's it for today. Talk to you later. See you.